In far-off galaxies, galactic invaders are at work. 3 times daily, a strange flash pulsates across our sky. It is hundreds of times stronger than all of the world's nuclear weapons put together. But it wasn't made by people, and if one happens close enough to Earth, it could wipe out all life there. Most people on Earth don't know about the possible dangers in space. Imagine this. A huge star explodes in our galaxy, the Milky Way, sending a deadly burst of energy hurtling toward our planet. This is a gamma-ray burst, which is the biggest blast since the Big Bang. There are no signs that something bad is about to happen, and then it strikes. The radiation that is pumped up heats up the high atmosphere. Our layer of ozone heats up. Across the atmosphere, human beings burns to death from radiation 100 times the fatal dose. When the ozone layer gets thinner, temperatures rise all over the world. This makes storms, tsunamis, and hurricanes happen. Most life on the surfaces of land and water incinerates. This may sound like science fiction, but if a gamma ray burst from 100 light years away hit Earth, it could happen. Gamma ray bursts are the most bright blasts in the universe. They must have a huge amount of power because they're so far away and yet still so bright. As much energy as the sun will give off in its full 10 billion year life. We know there are many planets and many stars in the universe, so gamma ray burst could have wiped out a lot of different cultures. In the 1960s, this strange blast of radiation was first seen. At first, because these gamma ray bursts are so bright, most scientists thought they came from our own galaxy, the Milky Way. There are a few reasons for that. One of them is that if they are outside the galaxy, the energy is almost too much to believe. But back then, even the most powerful telescopes couldn't figure out where they were or how far away they were because the burst only lasted a few seconds and then went away. But then, scientists started to wonder about their afterglow. Most blasts in space leave a glowing trail behind that can last for days or even weeks. In the late 1990s, satellites with better optics and X-ray monitors were finally able to catch the afterglow of a gamma-ray burst. It became clear that gamma-ray bursts actually came from outside our galaxy, millions and billions of light years away. So, their power had to be really out of this world. The brightness of the gamma-ray burst is the same as that of 1,000,000 trillion suns. This huge explosion could wipe out all life on Earth. But why do they happen? We are very sure that a common gamma-ray burst is caused by the death of a star that is at least 10 times the mass of the Sun. And these kinds of stars aren't very common. When a very big star dies, it falls apart and forms a black hole. Black holes are made when a mass of matter shrinks to a point where it is so dense that light can't get out. But experts think that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. In a matter of seconds, plasma jets shoot out from the poles where it spins. These beams of energy unleash dangerous gamma rays into space. At the same time, the gamma-ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme. Gamma-ray bursts are so bright because they take a huge amount of power and focus it on a very small area of the sky. Only one of every 300 gamma-ray bursts is directed toward us, so we only see one of those 300. Even if a gamma-ray burst happened not 100 but 1,000 light years away, the Earth could still be destroyed in a way that is similar to the end of the world. If a gamma-ray burst happens within 100 light years off the Earth, then it would be approximately 500 times brighter than the Sun and made in gamma rays. The energy sent to the high atmosphere of Earth would be the same as if 100,000 megatons of nuclear bombs went off. The ozone would be depleted, we'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear weather. So many species could go extinct all over the world. Now, the other side of the Earth would be a special place to be, because gamma rays don't go through the Earth, so you wouldn't get flash burned if you were there. However, the repercussions of altering the atmospheric composition and ozone depletion would ultimately come to the other side, and there, nobody knows what will happen. This nightmare scenario has a 1 in a trillion probability of occurring once in Earth's history. It's going to be a nasty day if you get caught in the beam, for the reason that this is extremely powerful radiation. You don't want to be in the vicinity of this sort of energy, since it has the potential to break down your own molecules. Currently, there is no way to protect humanity against gamma-ray bursts that occur in close proximity to Earth. They move at the rate of 186,000 miles per second, or the speed of light. By the time we detected them, they would have already struck our planet. Gamma-rays bursts could pose a hazard to the Earth or to anything living that came within their born sight. Astronomers think that gamma-ray bursts could be the cause of some mass extinctions on Earth. The one that happened 450 million years ago and killed off the Ordovician and Silurian species was probably the worst. Creatures that lived near the surface of the ocean were hit much harder than those that lived deep in the ocean. This is consistent with what would happen during a strong gamma-ray burst. In a galaxy the size of the Milky Way, gamma-ray bursts happen about once every few 100,000 years, according to astronomers. Even though they can be very bad, you have to be pretty close to be hurt by one. A gamma-ray burst happens about once every 5 million years, which is close enough to affect life on Earth. In other words, since the Earth was made 4.6 billion years ago, there have been about 1,000 events. So the chances of a close gamma-ray burst aren't zero, but they're low enough that you don't need to worry about them, unless you want to live for about 5 million years. Humanity obviously made it through the gamma-ray explosion unharmed, but this still demonstrates how far their effects may travel. Don't fret. Threats to Earth from gamma-ray bursts are extremely low. All of the closest contenders for gamma-ray bursts have been studied by astronomers, and none of them are either close enough or orientated in a way that would cause them to strike Earth. Therefore, what do you think? In our solar system, Earth shines like a sapphire jewel. We go about our daily lives without knowing the trouble could be coming from deep space. The routes that Earth and most other things take around the sun can be predicted. Most of the time, things are quiet and easy, but sometimes they get crazy and violent. Earth can be hit by space rocks, zapped by dangerous space weather, jolted, jostled, and threatened by the object's energy and cosmic forces. The Earth is on a wild ride through space that is often very dangerous. When you're moving fast in on a predetermined path, you hope nothing crosses because there's nothing you can do. Rusty Schweickart used to be an astronaut, so he knows how dangerous things in space can be. During the Apollo 9 flight in 1969, he was in charge of the lunar module. He is sending out warnings about the risks of an asteroid named Apophis that is getting too close to be safe. Everyone noticed him right away because the probability of impact was quite high. In fact, it was significantly greater than any effect probability we had seen before. Schweickart has a scary example from real life that shows how bad an asteroid, even one smaller than Apophis, can be when it hits. June 30th, 1908, 7:15 a.m. A half-football field-sized object came hurtling down from space at about 34,000 miles per hour and made a stream of fiery gas behind it. Within minutes, The fireball hit Earth's atmosphere and burst violently near the Tunguska Forest in Siberia. As a result, the explosion was the greatest ever recorded in the history of the planet. The explosion split the waves, which then set fire to 8 million trees in an area that was bigger than half of Rhode Island. Because the explosion happened in a place with few people, no one died directly from it. If that asteroid had hit just a few hours later, it would not have hit Siberia, but Europe. And if it had exploded in the air over one of Europe's biggest cities, 1 million people would have died. For the last 100 years, the Tunguska explosion has been shrouded in controversy. Many researchers now think an asteroid was the explosive trigger. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing on the concrete. Energy equivalent to 15 megatons of TNT was released in the Siberian explosion, making it 1,000 times greater than Hiroshima. Over a huge city, this would be catastrophic. NEOs, or near-Earth objects, were the name given by scientists to these trespassers. They are comets and asteroids, leftover debris from when the planets formed. The Oort cloud is a part of the Kuiper belt that extends past Neptune and is where comets travel. Between Jupiter and Mars, asteroids take a curved path, but their orbital trip isn't always routine. We don't have to worry too much about asteroids because they circle in a somewhat orderly belt between Mars and Jupiter. But when one gets away and all that mass and energy is going toward Earth, that's when the astronomers start to worry. It's not uncommon for cosmic debris to be jolted out of orbit and headed for Earth. The majority of it is evaporated by our planet's dense atmosphere. A larger object, however, is able to break through Earth's atmosphere and crash to the surface. Asteroids are a real and dangerous threat if you wish to look to the cosmos for the powers that would have us dead. Just like it did previously, it will happen again. 65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula, near the town of Chicxulub in Mexico, with a force of 100 million megatons of TNT. Here we see Earth hurling billions of tons of its crust into space, creating a blanket that blocks out sunlight, destroying the food web at its roots, and killing off countless species. The ferocious impact is thought to have been a factor in the extinction of the dinosaurs. We can think of asteroids as being bad things, but if it were not for an asteroid, we wouldn't be here today. Our mammal ancestors were running on their foot trying to avoid being appetizer for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a route and outcomes the primates, and among the primates, we have people. But it's strange that the same kind of cosmic boulder that made it possible for humans to live could one day wipe us out. In 1998, Congress asked NASA to find all near-Earth objects that were at least half a mile across, and what they found was unsettling. There are more than 850 NEOs near our vicinity. These asteroids are our nearest and most dangerous space friends. Finding these near-Earth objects is a bit like keeping an eye on storms. As you watch it day after day, you get a better idea of its path and can figure out where it's going, how big it is, and how fast it would hit the Earth if it did. By using telescopic technologies, NASA's SpaceGuard survey has detected over 90% of all near-Earth objects deemed harmful. These scary things could hit Earth with more power than all of the nuclear weapons on the world right now. Such an impact could trigger mass extinction. We wouldn't expect one to hit every few hundred, thousand, or millions of years, but if one did, it could wipe out different parts of the population. So there are events that happen very rarely but have big effects when they do. If they hit Earth, they would have impacts all over the world. They would not only wipe out a continent with very strong shock waves, but the debris would also be thrown into the air and land all over the planet, heating the air to 1,000 degrees. And all the vegetation all over the world where that happens would flash into flames. Smaller objects could also cause disasters. So Congress has asked NASA to find all NEOs with a diameter of 500 feet, which is as big as the Colosseum in Rome. A big object like that could wipe out a city or even a small state. Scientists are most worried about the asteroids they haven't found yet, not the ones they have found. Well, at the moment, there are about 2,000 objects that we can't say for sure won't hit Earth. We now have the technology to keep near-Earth objects from ever hitting Earth again. We can now literally start to change the local solar system to make it better for our life. The question is whether or not we will end up like the dinosaurs. It's hard to believe that the Earth has been around for more than 4.5 billion years because it's been through a lot since it was born. Asteroids that come into our orbit every year keep hitting our world like a boxer, but one day Earth could be knocked out. We've learned that near-Earth objects fly by us all the time, and we're getting more and more able to change our surroundings to help us stay alive. A rock in space named Apophis. In 2004, this pockmarked rock about 750 feet across came close to Earth. Now, it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029. So, in 2029, Apophis will get closer to us than our Rome communication satellites that circle the Earth. If you are in the right place, you will be able to see Apophis pass by the Earth with your own eyes. That's how close that rock is going to get. You won't even need binoculars. Over 99% of the time, Apophis will miss the Earth in 2029. However, if it passes the Earth at an exact distance of 18,893 miles, it may pass through a gravitational keyhole, a small area in space that is only a half-mile wide. If this happens, Apophis could be thrown off by the Earth's gravity, which could change its path. It could make Apophis come back and hit Earth on April 13, 2036, 7 years later. The gravitational effect of the Earth would cause it to bend, cause the Apophis's orbit to enlarge to precisely the size, which 7 years later it will come around and hit the Earth. At the present time, Apophis has 1 in 45,000 chance of delivering a deadly blow in 2036. It's one thing to say that there's a 1 in 45,000 chance that it will hit the Earth, but what you really want to know is if there's a 1 in 100, 1 in 10, or 1 in 1 chance that it will hit the Earth. We have to look at Apophis the same way we look at any natural disaster. You know the date of the hit, when it happened, and the angle of the orbit, so you can make a map. It starts in western Siberia, cuts across and down the Pacific Ocean near California, goes through Central America, and ends in Western Africa. Scientists have come up with a scary idea about where Apophis could strike. With a force of more than 1 million megatons of TNT, the asteroid could hit the Pacific Ocean off the coast of California. Such an impact would make a hole in the water 5 miles wide and 9,000 feet deep. This would cause tsunamis with waves up to 50 feet high to hit the coast, resulting in unimaginable human loss. If a rock 1,000 feet across hits the ocean, that's not a good thing. For that kind of thing, scientists are working on ways to stop such a cosmic strike from happening right now. A possible plan is to blow up an asteroid. But some people worry that this could make the problem worse by sending more pieces of the asteroid our way instead of just one. So, the new goal for experts is to change the path of asteroids that could hit Earth. Change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it. If we know about an asteroid far enough in advance, we can change its path. Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts. Now, the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids. If we are so careless that we keep doing nothing even though we know this is going to happen, that will be a real crime. Any asteroid hitting the Earth will require international disaster response. In addition, training is required in disaster and emergency management institutions and the public regarding the asteroid threat. It is important that everyone is aware of the level of threats and the potential to eliminate this threat. Apart from all these, amateur astronomers can work together with scientists to defend our planet. Amateur astronomers can help identify smaller and potentially destructive asteroids hidden in the universe. So would you like to be an amateur astronomer? Who knows? Maybe you can be one of the guards of our home. On a night in early September 1859, people all over America could see the aurora. It was blood red and so bright that when miners in the Rockies came out of their tunnels, they thought the sun was coming up. So bright, in fact, that even at midnight you could read a newspaper. It didn't just happen in the US. People all over the world saw these auroras. No one knew why they had happened. But earlier that same day, an astronomer had seen something on the sun's surface that he called a white light flare. Back then, the flare and the aurora seemed to have nothing to do with each other. But we now know that the spectacular aurora was caused by that flare, which was a coronal mass ejection. And if this violent event happens again, it could destroy our modern technological world. The sun is the most familiar thing in the sky. It gives all life on Earth heat and light. It is so big that it's hard to imagine, and it makes up 99% of the mass of the solar system. This nearly perfect sphere has a diameter of 1.4 million kilometers and was made by the burning of hydrogen and helium for the last 5 billion years. But from an astronomical point of view, it's nothing special. A G main sequence star, also known as a yellow dwarf. But looks don't always tell the whole story. Solar flares and explosions of plasma, particles, and radiation from its surface travel far into space. We call this process the solar wind. Solar storms, on the other hand, are very violent eruptions. And a coronal mass ejection, or CME, is the most dangerous because it has the potential to bring our high-tech society to its knees. Today, we'll find out how bad a CME could be and what astronomers are doing to keep an eye on our star to try to predict when they might happen. Step back in time to 1859. First, in Victorian Britain, it was okay for a gentleman to be interested in solar astronomy. And one man did it in a very good way, Carrington Richard Christopher. We don't know what he looked like, though, because there are no known portraits of him. Carrington learned many important things from what he saw. He saw that different latitudes rotated at slightly different speeds, which meant the sun wasn't a solid body, but a fluid one. But he also saw that sunspots could be the start of a solar storm. On Thursday, September 1, 1859, there were no clouds in the sky in the morning. So Carrington was doing what he always did, which was to look for sunspots. He was using his telescope to project an image onto a screen. At 11:18, he saw two brilliant beads of blinding white light appear in what Carrington calls a kind of conflagration. Stranger still, they were gone after 5 minutes for no clear reason. Carrington had seen a coronal mass ejection, which was a huge magnetic explosion. A huge cloud of charged particles that are thrown off the sun's surface. After 18 hours, the Earth was hit by an electromagnetic storm. People started calling it the Carrington event. At the time, everyone was talking about the beautiful aurora, which could be seen all over the world. Even though a few telegraph systems went a little crazy because of power surges, it didn't have much of an effect on everyday life. Don't forget, though, that this was 20 years before the light bulb was made. That was in the past. Things would be very different right now. Coronal mass ejections are common, but they can be different sizes and move in different directions. So, the question is, what are the chances that something like what happened in Carrington will happen today? And how would it change things? So, what is going on at the sun, on the surface of the sun, when we talk about the solar wind and space weather? The sun is made of magnetic fluid, and when that magnetic fluid rotates, it twists and distorts the magnetic field. A twisted magnetic field stores energy, which can lead to eruptions, which are called mass ejections. And these explosions are huge, sending out 1 billion tons of material at 1,000,000 miles per hour. So, we want to know where these things are going, because if they move toward Earth, they could affect the technologies we use. There's a very famous event in Quebec in 1989, where some power systems were disrupted for many hours in October. We've heard about the Carrington event, which happened in the 1800s. What would happen if it happened today, and how would it affect us? If we think about what we use satellites for now, we have GPS spacecraft that help us find our way, communication satellites, weather satellites, and even the stock markets are linked in some way. But we also have bigger power grids and a lot of wireless technology, and we don't know how they will react. How likely is it that something like the Carrington event could happen again? We know that the sun can still make these things happen. In 2012, there was an event that luckily didn't come toward Earth, but it did pass over one of the spacecraft we use to watch the solar wind. And it pushed all the sensors on that spaceship to their limits. So from what we've learned, we think that was at least as powerful as the Carrington event, and maybe even more so. It's just a coincidence that a big CME and one that's headed toward Earth both happened at the same time. And that's mostly just a matter of luck. We either get one or we don't. And how do we do with making predictions? Can we predict what the sun will do in a week, a month, or a year? Once ACME is up and running, we can start making predictions so that we can figure out how big it is, how fast it's moving, and most importantly, where it's going. All of this sounds very scary. Space weather is a problem, and the UK government knows this. The National Risk Register lists it. It's about as bad as a pandemic of flu. So, the people who make spacecraft are trying to find out what the most extreme conditions are in space, so they can make them so that they can handle those conditions to a certain degree. Both NASA and ESA are getting ready to send satellites into space that will get closer to the sun than ever before. The MET office's Space Weather Operations Center opened in 2014. It is one of only 3 places in the world that can predict the sun's effects on Earth around the clock. So far, the sun has had almost no sunspots, and the side that faces Earth is not expected to have any more sunspots or CMEs that are important. So luckily, there isn't much going on right now, and things don't look too different in the long run. So, spacecraft, satellites, power supplies should be safe for the foreseeable future. Trouble is, the foreseeable future in space weather forecast is, at most, just a few days. We still don't know a lot about CMEs, like where they're going, how big they are, or when they might happen in the future. 2 new solar probes will get closer to the Sun than any other spacecraft has ever done. The Parker Solar Probe was supposed to be sent into space, and its destination will be close enough to the Sun's surface to fly through the source of the most energetic solar particles. The Parker Solar Probe is an exploration mission that will measure the gas and magnetic field near the Sun to figure out why this stuff is spreading out into the rest of the solar system. And this, the Solar Orbiter from ESA. Solar Orbiter might find out how sunspots, flares, and coronal mass ejections on the Sun's surface are related to the solar wind. Solar Orbiter's success will be very important for our understanding of how the Sun works. We think that the Sun's magnetic field is made in a way similar to how Earth's is, but it is much more dynamic and changes all the time. We have an 11-year sunspot cycle during which the Sun's magnetic fields move towards the poles and the polarity changes. On top of that, the magnetic field goes out into the solar system and flows over all of the planets. Solar Orbiter will measure these magnetic fields for the first time, and it will also give us the chance to watch the magnetic fields move to the Sun's poles. To do this, Solar Orbiter will take pictures of the Sun's atmosphere and measure the number, speed, and temperature of the particles moving across the space between the Sun and Earth. But the magnetometer, which is made to measure the tiny magnetic fields in space that are carried by the solar wind, could be one of the most important and sensitive instruments. The Sun is ever present in our lives. It gives us light, warmth, and even life itself. For Richard Carrington, who was the first person to record ACME, it was just a strange event. But now we know that these things can do a lot of damage to the world we live in. With new satellites and more observations, we might be able to learn more about these events and predict when the next coronal mass ejection will happen. Nothing existed at the outset. After then, the cosmos began to take shape some 13.7 billion years ago. How this came to be, or if there was ever a time before, time is still a mystery. Yet, physicists have pieced together an approximate timeline of significant events in the cosmos's existence using telescope data and models of particle physics. From its beginning to its inevitable demise, we examine key points in the evolution of our universe here. Welcome to the Endless Universe. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. The Big Bang. The Big Bang is a moment in time, not a location in space, from whence all else unfolded. To be more precise, it's the first second of time, the point in history from which all other seconds have been measured. The Big Bang, despite its common name, was not an explosion, but rather a time when the universe was incredibly hot and dense before space began to expand outward in all directions simultaneously. The Big Bang scenario suggests that the universe was an infinitesimally small point of infinite density. However, this is merely a convenient way of expressing that we don't know for sure what happened at that time. We now understand the cosmos to break down at the Big Bang because mathematical infinities don't make sense in physics equations. Cosmic Inflation Era. The next cosmic confab was to rapidly expand in size. The universe may have expanded exponentially after the Big Bang, tearing off previously colliding parts of space. This period, known as inflation, is still mostly theoretical, but it has gained favor among cosmologists as a possible explanation for the striking similarity between distant parts of space. Attempts to detect this expansion in light from the early cosmos were reported in 2014. Nevertheless, further investigation revealed that the true culprit was nothing more than interplanetary dust causing interference. Quark-gluon plasma. The temperature of the early cosmos was between 7 trillion and 10 trillion degrees Fahrenheit, or 4 trillion and 6 trillion degrees Celsius, just a few milliseconds after the Big Bang. Quarks, elementary particles ordinarily contained within protons and neutrons, were free to move about at these temperatures. These quarks were combined with gluons, carriers of the basic force known as the strong force, in a primordial that pervaded the whole universe. In particle accelerators on Earth, scientists have replicated these circumstances. In both terrestrial atom smashers and the early cosmos, the challenging to achieve condition only lasted for a few fractions of a second. The early epoch. The subsequent period of time, beginning perhaps in the neighborhood of a few thousandths of a second following the Big Bang, was a period of intense activity. The universe chilled as it expanded, creating an environment conducive to the merger of quarks into protons and neutrons. The cosmic neutrino background, which has not yet been detected by scientists, was created 1 second after the Big Bang, when the density of the cosmos decreased sufficiently for neutrinos to sail across space without interacting with anything. The first atoms. Protons and neutrons fused together during the first 3 minutes of the universe's existence, creating the isotope of hydrogen known as deuterium, along with helium and a trace quantity of the next lightest element, lithium. Yet, this procedure ceased as the temperature dropped. As temperatures settled down 380,000 years after the Big Bang, hydrogen and helium atoms could join with free electrons to form the first neutral atoms. The cosmic microwave background, a remnant of this epoch first identified in 1965, was created when photons that had previously collided with electrons were able to flow without being disrupted. The Dark Ages. There was a lengthy period of time when nothing in the cosmos emitted any light. The cosmic Dark Ages refer to this time frame of around 100 million years. Because practically all of what astronomers know about the cosmos can be gleaned by studying starlight, this era remains exceptionally challenging to study. It's hard to piece together what happened if there are no stars to guide us. The first stars. The first stars were formed when hydrogen and helium began to compress into massive spheres, some 180 million years after the Big Bang, creating hellish temperatures at their centers. After the neutral hydrogen atoms in interstellar space were broken apart into protons and electrons by the intense photons generated by early stars and galaxies, the cosmos entered a period known as cosmic dawn or reionization. It's hard to put a time limit on reionization. As it happened so soon after the Big Bang, its signals have been masked by subsequent gas and dust. Thus, the most that scientists can determine is that it was finished by around 500 million years after the Great Bang. Large-scale structure. Almost 1 billion years after the Big Bang, supermassive black holes developed at the cores of merging early galaxies. Intense quasars, visible from 12 billion light-years away, switched on and began emitting their bright beams of light. The universe's middle years. Throughout the subsequent few billion years, the cosmos underwent more evolution. Denser regions in the early cosmos drew more material due to gravity. A gorgeous filamentary cosmic web is the result of them slowly expanding into galaxy clusters and lengthy strands of gas and dust. Birth of the solar system. A yellow star with rings around it formed from a cloud of gas around 4.5 billion years ago in one galaxy. These accreted rings eventually became the 8 planets of our solar system, as well as numerous comets, asteroids, dwarf planets, and moons. Either the third planet out from the sun retained a lot of water via this process, or it received a deluge of ice and water from comets later on. Earth and humanity. Little primitive bacteria appeared on that third watery world between 3.8 and 3.5 billion years ago. These organisms arose and progressed into amazing marine monsters and enormous dinosaurs that fed on leaves. Some 200,000 years ago, upright beings emerged, capable of contemplating the vastness of space and learning about the universe's origins. The end, or not. It isn't the final chapter, of course. The future of the cosmos is still a mystery to physicists. It is dependent on our ability to accurately quantify the characteristics of dark energy, the unknown factor thought to be accelerating the expansion of the universe. All the stars and all the galaxies will have burned out, and even black holes will evaporate into nothing if the universe continues to expand forever, leaving behind a lifeless cosmos saturated with inert energy if this scenario comes to pass. Alternatively, the Great Crunch, a reversal of the Big Bang in which gravity triumphs over dark energy's expansionary force, will occur. The Great Rip, in which the cosmos rips itself apart, is another possibility if dark energy accelerates everything apart to greater and greater distances. Thanks for watching, and don't forget to hit the like button, subscribe, and turn on notifications for more content like this in the future. Our solar system is a harsh environment. Volcanoes are destructive everywhere, from the ice volcanoes of Saturn's moon, Enceladus, to the immense lava fields of Jupiter's moon, Io, to our own planet Earth. It is truly true that we would not be here if there were no volcanoes. Volcanoes influence and alter our climate. Volcanoes are both the creators and destroyers of existence. Today's spacecraft and observatories have revealed volcanoes on planets we once believed to be dead. The discovery of volcanoes on an object smaller than the moon was a major surprise. If there are volcanoes on other worlds, could there also be life? Volcanoes are among the most potent natural occurrences on Earth. They create new land, destroy the old. They emit gases that alter the atmosphere we breathe. Deep in our oceans, volcanic heat fuels bizarre new forms of life. Volcanoes help sustain life on Earth. Now we look for signs of life on other planets. We understand that life requires water. We are aware that it requires energy. And this is where volcanoes come in, as they generate tremendous quantities of energy. If we locate volcanoes on other planets, we may discover life. The search begins with this planet, which orbits the Earth closest. Venus, a planet that closely resembles our own. Venus and Earth have similar masses. Earth and Venus were very similar 3 billion years ago, with new land, new oceans, and an atmosphere. Both planets was conducive to life. On Venus, however, something went awry. Something caused the history of Venus to diverge drastically from that of Earth. Venus took a definite turn to the dark side a long time ago. Venus is Hell, our malevolent twin planet. Today, the surface of Venus is like a furnace. The surface is 900 degrees Fahrenheit hot. It is actually heated enough to melt some metals, so you have no chance. Venus is a greenhouse world. Its atmosphere contains a high concentration of carbon dioxide. It absorbs solar heat like a blanket. Actual images of Venus's surface reveal a desolate, extremely hot desolation. The planet was annihilated by dense CO2 atmosphere. The CO2 was produced by volcanoes. Spacecraft in orbit provided the initial clues. Radar broke through Venus's thick clouds and showed volcanic formations all over the planet. These formations look a lot like the shield volcanoes on Earth. Round and flat, shield volcanoes derive their name from their shape. These volcanoes ooze, but they ooze for thousands of years. Once we were able to map the entire surface of Venus using cloud-penetrating radar, we began to examine its landforms and discovered that many of them were quite familiar. In particular, we observed enormous shield volcanoes that resembled the shield volcanoes in Hawaii. The radar images of Venus were identical to those of Hawaii's shield volcanoes. In the past, Venus was home to volcanoes. We were astounded to see a picture of Venus for the first time. We discovered a cratered volcanic surface. There are at least 1,000 large volcanoes and possibly tens or hundreds of thousands of lesser ones. Lava plains cover 3/4 of Venus's surface, evidence of an ancient catastrophe. This could have been a home for life. It was instead consumed by flames. Numerous trillions of tons of carbon dioxide were expelled by Venus's volcanoes into the planet's atmosphere. The temperature rose dramatically. The oceans evaporated. On Earth, carbon dioxide is able to absorb into the rocks. It can be absorbed by the ocean. On Venus, however, there is no water, and the temperature is so high that carbon dioxide cannot even combine with the minerals. Volcanoes released carbon dioxide into the atmosphere eons ago, and as time passed, fewer and fewer methods existed to remove it from the atmosphere. Volcanoes sanitized the entire planet if Venus ever supported life. Earth is the only known planet with life. That may alter. This is the gas giant Jupiter, with its moons believed to be frozen and lifeless. A mystery surfaces as a cloud hovering over a cold and lifeless world upon closer inspection. On Venus, volcanoes transformed a planet similar to Earth into a hyperheated inferno. Volcanoes on a planet similar to Earth were not a surprise, but the discovery of volcanoes on the Moon was an astonishment. In March 1979, the Voyager 1 spacecraft provided us with our first up-close look at Jupiter's minuscule moon Io, a world we once believed to be frozen and lifeless. And they witnessed something odd. They observed this arc next to the moon, and it almost appeared as though there was a second moon behind it. We scratched our minds and asked, what could that be? Everyone is aware that Io is lifeless, dull, and uninteresting. And then people realized, oh my God, it's a volcanic eruption. We discovered that the area is engulfed in volcanoes. It is geologically extremely active. There are constant volcanic eruptions. And what they're erupting is a great deal of sulfur, which becomes extremely heated. And sulfur changes color as its temperature changes. It may be red, orange, yellow, or even black. As a result, these images of Io's visage resemble a pizza with various types of cheese and olives where the small black spots are. Io is not dead. It is alive and growing. There are more than 400 active volcanoes. The largest, Pelee, erupts from a gigantic lava lake. It extends approximately 400 kilometers into space. It would be an extraordinary sight if we could stand on the edge of that lava lake and observe that plume shooting off into the void of space. Pele's eruptions are so massive due to Io's diminutive size. There is nothing holding the lava back, as there is virtually no atmosphere and little gravity. These enormous eruptions make Earth's volcanoes resemble fireworks. How can a moon so small be so volcanic? The answer is Jupiter. Similar to how the moon raises the tides in Earth's oceans, Jupiter raises solid rock tides on Io. The orbit of Io around Jupiter is not circular. Sometimes it's closer, sometimes farther away. Jupiter exerts a gravitational force on Io. Jupiter's gravity stretches and squeezes Io. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates extreme heat and enormous pressure. Wherever there are weak spots in the crust, lava erupts. Volcanism is therefore planet scale. In contrast to Earth, where certain portions are active around the plates or in weak areas, this is an entire moon that's one active hotspot. Io is the most volcanism-active planet in the solar system as a result of the immense power of gravity. Volcanic activity on Io has taught us something new. It taught us that internal energy sources can drive volcanism in a manner distinct from that on Earth. Io is a lava world that is extremely hot and violent. It is difficult to conceive of anything surviving there. We have discovered strange eruptions on numerous planets and moons. But so far, the only world where volcanoes are linked to life is ours, or so we thought. This is Europa. It orbits Jupiter at a distance of nearly 500 million miles from the Sun and is a 2,000-mile wide sphere of ice. From afar, its surface appears to be polished. Up close, it's a different story. Europa is pummeled by Jupiter's immense gravity, just like its companion Io. The surface rises and bends, forming ridges and deep fissures. When we first obtained close-up images of Jupiter's moon Europa, they seemed vaguely familiar, and it turns out that they resemble Arctic ice flows. And it turns out they are the same. A global liquid ocean lies beneath Europa's several-mile thick, icy crust. Magnetic measurements indicate Europa's ocean is an astounding 60 miles deep. The gravitational impact of Jupiter heating the rocky interior and melts the ice above. As the core is stretched by tides and heated, possibly melting, it is not preposterous to believe that there is a boundary between a hot core and a liquid water ocean. Underwater eruptions on Earth are surrounded by life. The same may occur on Europa. Here, the darkness is complete. The pressure, a crushing 2,000 Earth atmospheres. A harsh environment, but perhaps a cradle for life. If there is evidence of life on Earth, why not Europa? An energy source, volcanic activity, a universal solvent, liquid water, and a complex hydrocarbon chemistry are all present. Life would be difficult, but not impossible on Europa. There is life at every extreme on Earth, including searing heat, crushing pressure, and absolute darkness. Life on Europa may resemble our own in unanticipated ways. If life exists beneath Europa's ice, it would be aquatic, but without eyes, because there is no significant light. Organisms that essentially feed off the energy of the volcano would most likely utilize sonar to make sense of their surroundings. Volcanoes on Europa could be the genesis of new life. It is even conceivable that Europa is typical, that this is the norm for planets with life. Earth may represent an exception. Consider that Europa could serve as a model for the billions of moons in the universe with liquid oceans. So, all of a sudden, our horizons have expanded several billion times by looking at the moons of Jupiter. Our solar system is home to more than 170 moons. Multiply this by the size of the universe, and that's a lot of potential habitats for life. Only liquid water and a source of energy are required. Potentially, both are provided by volcanoes, and they are ubiquitous. This is Saturn, twice as far from the Sun as Jupiter. However, it also has volcanic moons, and similar to Europa, these moons could support life. Saturn is one of the odd planets in our solar system, with a 600,000-mile-wide ring system, an astounding 62 moons, and one with a secret. Enceladus is one of the lesser and more distant moons of Saturn, and it's been known for a long time that it's covered in ice due to its extremely brilliant and reflective surface. However, when the Cassini spacecraft visited the planet, it made a remarkable discovery. Not on the planet itself, but on Enceladus did the Cassini probe disclose a remarkable discovery. A massive plume, backlit by the sun and erupting into space, is conclusive evidence of volcanic activity. Cassini's sensors zoom in on the south pole of the moon to capture these enormous craters scarring its surface. At the south pole of Enceladus, there are extraordinarily large fissures which open and close as Enceladus orbits Saturn due to the tides. Now, these fissures are enormous. They extend for hundreds of kilometers. And when they begin to open, you would see a large crevasse opening at approximately 100 miles per hour along its length. It'd be incredibly spectacular. Huge gravitational forces cause the surface to open and contract with incredible velocity. This helps produce the heat necessary to dissolve ice and form oceans beneath the surface. The conditions of the water beneath the surface of Enceladus are ideal for life. It is at the ideal temperature. It would be beneficial for life. Liquid water would be just like seawater here on Earth. And the chemistry of the water we observe erupting from these fissures suggests that it contains salt. It contains organic matter as well. Therefore, we have identified a location in the solar system where there is a strong possibility that there is life right now. In the ice particles, Cassini has detected complex carbon molecules. In conjunction with liquid water, they suggest that perhaps life could exist deep within this mysterious moon. Enceladus is possibly not alone. Another of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system, the only moon with a thick atmosphere, a frozen world, ice as hard as rock, lakes of liquid methane. Yet, we may also discover evidence of volcanoes and the tantalizing possibility of extraterrestrial life on this planet. Volcanoes are one of the most destructive forces in the universe, as evidenced by Io's raging conflagration and Triton's ice and nitrogen explosions. Even on Saturn's enigmatic moon Titan, however, destruction can lead to the prospect of life. It has a diameter of 3,000 miles, making it larger than Mercury. It has the thickest atmosphere of any moon in our solar system. There is weather, including cyclones, winds, rain, and even lakes, but the temperature is so low that liquid methane replaces water, and it's loaded with essential compounds for life. Titan has proven to be one of the most fascinating locations in the solar system. It's an active world. It is the only moon with a dense atmosphere, an atmosphere very similar to that of Earth due to the presence of nitrogen and, as it turns out, organic molecules. High in Titan's atmosphere, methane gas reacts with sunlight to produce compounds essential to life. But if sunlight consistently converts methane into organic compounds, why does methane not run out? Methane is abundant in the atmosphere, but we know that it is quickly eliminated by sunlight, so it shouldn't be there. There must exist a source of methane. Something on Titan emits methane in a continuous stream. Cassini has spotted what appears to be a crater. Infrared cameras disclose that the crater is surrounded by various types of materials. Scientists believe the green areas may be volcanic, possibly plains of lava ejected from Titan's interior. On Titan, the boiling liquid emitted by volcanoes could be either ammonia or water. Methane and ethane are emitted by Titan's volcanoes, and this is likely the cause of the planet's extremely dense cloud cover and orange atmosphere. This atmosphere likely originated from the outgassing of Titan's volcanoes. Even on a globe as frigid as Titan, volcanoes require heat. On Titan, there are two sources of heat. Radioactive substances heat the interior, and Saturn's enormous gravity caresses the moon, similar to Enceladus. These two forces produce sufficient heat to transform ice into water and liquid methane into gas. Could volcanoes on Titan give life a chance to survive here? The chemical reactions necessary for life as we know it require an atmosphere, a solid surface, liquid water, and heat. Volcanoes could provide everything on Titan. If life does exist on Titan, it would be truly alien. It would breathe hydrogen instead of oxygen and possibly swim through methane reservoirs at 300 degrees below zero. There may be oceans of ethane. Possibly, there are tidal pools as well as volcanic and hydrothermal activity. Perhaps volcanic heat could produce enough energy to support life on Titan. That's a speculation, but it can't be ruled out. However, we may not need to travel so far to discover signs of life. We may discover it on Mars, a volcanism-rich world much closer to home. Volcanoes are ubiquitous throughout the solar system. Planets such as Io, Titan, and Triton are intricate, volatile, and violent. Once, we believed that Earth was the only planet with both volcanoes and life. Now, we find volcanoes everywhere, but alien life has yet to be discovered. Volcanoes exemplify the absolute force of creation and destruction. They go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. Volcanic cauldrons are the birthplace of life. Volcanoes create new landscapes, seed the atmosphere with complex chemicals, replace the old with the new. If volcanoes are linked to the processes of life, where is life on other planets? Perhaps the origin of the answer lies in ancient times, when the solar system was immature on a planet similar to our own. This is the planet Mars. 3 billion years ago, volcanoes were active. The greatest volcano in the solar system still stands. The cliffs leading up to it are greater than 6 miles in height. Even Mount Everest would be comfortable in their shadow. This is the formidable Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A structure of this magnitude takes millions of years to construct, a period of time that volcanoes on Earth never have. The Earth's crust is constantly in motion. In the depths of the Earth, a solitary hotspot forces magma to the surface, creating a new volcanic island. While the hot point remains stationary, the surface is in motion. The new island moves away from the hot location and is replaced by a new volcanic island. Mars is different. The crust is locked solid. On Mars, there is simply no tectonic activity. The crust is one big solid plate, and so if there's a hot spot, it just sits there and builds and builds and builds. And you get a larger and bigger volcano. Therefore, Olympus Mons is so enormous. Today, Olympus Mons is an icy remnant of a distant, warmer era. Olympus, an extinct volcano on a fading planet, is now a veritable colossus due to Mars's diminished atmosphere. However, the ancient volcanic terrain of Mars could one day support life. The evidence is readily available on Earth. Volcanoes on Hawaii have formed enigmatic tunnels known as lava tubes, which are formed when rivers of molten rock rush into the ocean. Lava tunnels are formed when there is an underground river of basaltic lava, magma, and molten rock at 2,000 degrees Fahrenheit. Imagine it as an icy river with a crust of ice forming on the surface. It's the same, except here, the crust is solid rock and the river continues to flow beneath, creating this cave, this lava conduit. Recent images imply that Mars volcanoes may have also created lava tubes. Any rocky planet with basaltic volcanism will likely contain lava pipelines. Now, after possibly millions of years of inactivity, these lava tunnels could revive life on the red planet. This existence will be our own. Radiation will be one of the obstacles that future humans will face when attempting to live on Mars. And especially during solar cyclones, the incoming cosmic rays can be lethal. The tunnels and caverns of Mars's extinct volcanoes could one day serve as an ideal home, retaining air and shielding us from harmful radiation. A long-dead volcano could help fill a world with new light. Volcanoes are capable of both destruction and creation. We used to only know about the planets that circled around our sun. But now we know that there are rocky worlds and huge gas clouds that circle other stars. They have a great story to tell. The early history of these planets would have been very, very violent. Planets are made the same way everywhere. They come from the dust and other things that are left over after stars are born. So, if they're all made the same way, what makes them so different? As it turns out, the universe is full of galaxies, gas clouds, stars, and planets. There are 8 worlds in our Sun system. But now we know that they are just a small part of the huge family of planets in the sky. It's a very important moment in the history of science to be sure that there are other systems of planets out there. And in our Milky Way galaxy, which has 200 billion stars, there are probably dozens of planets. NASA sent the Kepler Space Telescope out into space in 2009 on a 6-year mission to find new planets that orbit other stars. So far, they have found more than 400. Some are huge, spinning balls of gas that are 5 times as big as Jupiter. Others are huge, rocky worlds, many times larger than Earth. Some follow wild, erratic orbits, so close to a star they're burning up. One thing is clear: no 2 planets are the same. Each one is unique. But most of these new worlds are very far away and hard to study. Most of what we know about how planets work comes from the 8 that circle our Sun. Our own planets come in 2 main types. There are 4 rocky planets in the inner solar system: Mercury, Venus, Earth, and Mars. And in the outer solar system, there are 4 giant gas planets: Jupiter, Saturn, Uranus, and Neptune. Each of the 8 worlds is very different from the other 7. When our solar system was born 4.6 billion years ago, they started to develop their own personalities. When the sun ignited, it released a massive cloud of gas and dust into space. All 8 planets, including the metal planets closer to the sun and the gas planets farther away, came from this cloud of space debris. All of the worlds in our solar system are made of the same materials. They're made from the same cloud of gas and dust, but they formed under very different conditions. Some of them formed close to the sun, where it was much hotter, and some formed far away, where it was much colder. And since the situations were so different, the things that came out of them were also different. So, at the beginning of the solar system, there was a pretty even mix of silicates, water vapor, hydrogen, a lot of hydrogen, methane, and other things. These elements in the dust cloud are like ingredients in a cake. They cook in different ways based on how the ingredients are mixed and how hot the oven is. And you'd mix the ingredients just like you did with the cake. Then you'd put it in the oven and bake it, and it would change. So basically, this is what happened in the solar system. Overall, the planet cooks in a slightly different way, depending on how close it is to the sun. Near the sun, where it is hot, gases are burned off and water boiled away. Only materials that stay solid at high temperatures, like metals and rocks, can survive. This is why only rocky planets form close to the sun. As a planet moves farther away from the sun, it cooks in a different way. But what kind of planets will form depends on what's in the cloud. Based on what kind of cloud a solar system forms in, it might not have any rocky planets because it didn't have enough materials to make something like Earth. Instead, it might have more gas giants and none at all. If you want planets that are made of rock, you need a cloud full of metals and rocks. The next step is to turn down the heat. As it cools, some of the things in it that have a high boiling point start to condense out as solids. And these very small mineral grains can start to form. These tiny pieces of rock and minerals are the beginnings of a new rocky world. They start to stick together over time. If you had one dust molecule and another dust molecule, and they would basically hit each other and make one slightly bigger dust molecule, and they'd keep getting more and more. This process is called accretion. As these things got bigger, they became basically rocks. Then rocks slam into other rocks and form boulders. Boulders smash together to form bigger boulders. At some point, you'll have something big enough that its weight is strong enough to start pulling things towards it. So instead of just crashing into things and getting bigger that way, it was actively pulling things in. At first, there were a lot of young planets in our own solar system, maybe 100. Most of them didn't make it. If you go to the asteroid belt and look at the asteroid 4 Vesta, you can get a good idea of how big a hard planet has to be before it can pull itself into a sphere shape. Vesta is only 329 miles across, which isn't quite big enough to be a sphere. To become round, a growing planet needs to be 500 miles across. Then, it has enough gravity to crush it into a sphere. Any smaller, and it stays in irregular shape. Every time a round baby planet crashes into something, it makes it hotter and hotter until it starts to melt. Gravity is now starting to sort the heavy things from the lighter ones. Lighter things tend to float up and form a crusty layer, while heavy things, like most metals, fall down and form a much denser core at the planet's center. Finally, the young planets are starting to look like planets. But now, they have to make it through a time of violence and destruction, a cruel time that will decide which planets will live and which will die. After the sun was made, all 8 of our planets came from the same cloud of dust and gas, but they turned out to be very different. There was no real plan for how each of the new planets should be made. They did follow the rules of physics and chemistry, but most of what happened was just a matter of luck. About 4.5 billion years ago, our sun was surrounded by about 100 young planets. It turned into a demolition derby. Planet hit planet. Most were wiped out. The early history of these planets would have been very, very violent, with many of these collisions happening in the last stages of each planet's growth. As these collisions happened and things ran into each other, some of the planetesimals started to grow at the expense of the others. And these things that would eventually become planets grew and grew. As they got bigger, they sucked up all the smaller planetesimals around them, which caused a lot of space debris to hit the surface of the protoplanet. After it was over, there were only 4 different rocky planets left. Because of the things that happened to each planet in the past, they are all so different from each other. Mars is a frozen wasteland. Earth flows with liquid water. Venus is a place full of volcanoes. And Mercury is small, empty, and very hot because of a huge crash. Mercury, for example, has a very thin crust and is very dense. So, it could have been a bigger planet in the past. Then something hit it at an angle, which tore off the lighter crust and left only the dense center. Also hit hard was the young Earth. At the end of the Earth's development, it was hit by something else, which tore apart its mantle and sent the pieces into orbit around the Earth, where they regathered to form the Moon. Something also seems to have crashed into Mars. The crust of the Earth is thinner in the north than in the south. One idea about what might have caused this is that the northern hemisphere of Mars was hit by something early in the planet's history, which blew off a lot of its crust, and that crust started to build up again in the south of Mars. There were 2 effects of all these collisions. They cut down on the number of baby planets that were still alive, and they brought more ingredients to the survivors. If you had a collision with something that was metal, rich, those chunks would tend to descend down into what was becoming the core, where if you collided with something light or icy, they would tend to just float about and form part of the crust instead. Near the Sun, there were 4 rocky planets that were almost done. They were made of a solid core of hot iron surrounded by a layer of liquid iron and a shell of molten rock. On top of that is a crust on the surface. All of these rocky planets were made the same way from the same basic materials. But each of them was very different. Different sizes and very different destinies. Space may look empty, but it's not. It's full of stuff blown out of the sun. Strong magnetic fields are made by the sun. These fields rise up in giant loops above the surface. When they hit each other, a storm of very hot, very charged particles shoots out into space. The name for it is the solar wind. Astronauts can see it from space, but only when they close their eyes. When you close your eyes, you sometimes see a little flash. And that flash of light is caused by an energetic particle going through your head and interacting with the fluid in your eye, and you see one of these every few minutes. Solar wind could kill the astronauts if they were exposed to a lot more of it. During the Apollo program, there was an explosion on the sun between 2 moon missions that would have killed the astronauts if they were there. So, radiation in space is a big deal. But here on Earth, the solar wind doesn't pose much of a threat because we are protected by an invisible magnetic field that comes from the center of the Earth. You can make magnetic fields from motion by converting the energy of the motion into magnetic energy. Deep inside the Earth, the same thing happens. As the Earth spins, the hot liquid metal flows around the solid core, turning its energy into a magnetic field that comes out of the poles. It keeps the solar wind from getting into the atmosphere of the planet. And if the planet has a magnetic field, the magnetic field will send the solar wind around the planet. The solar wind is pushed away from Earth by the magnetic field, which protects the atmosphere and everything on the surface. Big storms of solar radiation can sometimes mix up the magnetic field. Then, big light shows called auroras happen over the poles. Without a magnetic force field, Earth's atmosphere and water would be blown away by the solar wind, leaving a planet that is dead and dry, a lot like Mars. Mars was made the same way Earth was, but today it's cold and dry and there's not much going on. So why have the two planets changed so much? NASA sent 2 robots to Mars in 2004 to find out what was there. The Spirit and Opportunity rovers looked at miles of the surface of Mars. They proved that Mars is a dry, dangerous desert with only the atmosphere of Earth. But they did find signs that water used to be there. Mars wasn't always a dry, barren place. We have found strong evidence that water was once below the surface, rose to the surface, and evaporated away. In a few places, we can also see ripples that are made when water flows over sand. So, not only was there water under the ground, it had flowed across the surface. If Mars used to have water, it probably also had a lot of atmosphere around it. So what happened? We can see that there were volcanoes on Mars in the past, so it had a hot interior at some point. And because it was made of the same stuff as Earth, it would have had a hot iron core surrounded by liquid metal in the middle. It should have also had a magnetic field. The question is, where did it go? Early in the planet's history, Mars apparently had a strong magnetic field. And it was probably caused in the same way as it is on Earth. But Mars is a smaller planet than Earth. Because of this, it will lose heat more quickly. And that means that a liquid core can become solid when it freezes. If you completely freeze the core, the convection will stop, the flow stops, and the magnetic field disappears. As soon as the magnetic shield stopped working, the solar wind blew away the atmosphere and the water evaporated. Mars turned into a cold, empty place. The rocky planets, Mars, Earth, Venus, and Mercury, all formed within 150 million miles of the Sun. But 4 times farther out, the Sun baked a very different kind of planet. These monsters are very big, made of gas, and have no solid surfaces at all. So far, astronomers have found more than 400 new planets in solar systems far away. Almost every one of them is huge and made of gas. Our solar system has 4 of these so-called gas giants: Jupiter, Saturn, Uranus, Neptune, all of which have thick, soupy atmospheres with lots of hydrogen, helium, and methane. Why are these outer 4 made of gas when the inner ones are rocky? It's very cold here, 500 million miles from the Sun. At the start of the solar system, there was some dust, but mostly gas and water, frozen in ice grains. It was cold enough to make solid snow where the big planets began to form. And we think that we were able to make ice snowflakes, and that these were able to stick together to form the cores of the giant planets. We think that's why the big planets might have grown so big. Because there was so much ice and gas, their cores grew to be about 10 times the size of Earth. A lot of gravity came from these big cores. They had so much pull that they sucked in all the gas around them and made thick, soupy atmospheres that went down tens of thousands of miles. The more gravity they made, the bigger they got. More and more dust and debris kept getting pulled towards the planets, and this is what made up their moons. Each of Jupiter and Saturn has more than 60 moons. The gas planets have something else that makes them unique: rings. Saturn is different from the other planets because it has these beautiful rings. It turns out that Jupiter, Uranus, and Neptune also have rings, but they are very weak and hard to find. But they are there. There are rings around all four of the gas giants, but Saturn's are the most obvious. From far away, Saturn's rings look like a single flat disk, but in reality, they are made up of thousands of small rings that are only a few miles wide each. When the Cassini probe flew by, it found that billions of pieces of ice and space debris were moving around inside the rings at up to 50,000 miles per hour. These pieces of ice and rock hit each other all the time. Some of them turn into small moons. Some of them fall apart. But they never grow bigger because Saturn's huge gravity pulls them apart. Scientists are just now starting to figure out how the rings came to be. The idea is that a comet hit a moon and knocked it out of its orbit, bringing it closer to the planet. Saturn's gravity tore it to pieces. All of that stuff got stuck in rings that went around the planet. But the real mysteries of the gas giants are deep inside them, tens of thousands of miles below the clouds. Here is where things really get going. It's a place so extreme that it goes against the natural laws. Most of the new planets we find orbiting faraway stars are huge gas planets. They are so big that Jupiter seems small next to them. But nobody knows what happens inside gas giant planets, whether they are in our solar system or far away. We know that Jupiter's thick atmosphere goes down 40,000 miles, and we can see bands of gas moving at high speeds that make violent storms on its surface. But we don't know what's happening inside, far below the storms. NASA sent the Galileo spacecraft on a 14-year trip to Jupiter to find out. December 7, 1995, Galileo sent a probe into Jupiter's atmosphere, which it did at a speed of 160,000 miles per hour. As it fell through the thick air, the parachute slowed it down. It saw lightning in the clouds and 450-mile-per-hour winds. The probe transmitted data back to Earth for 58 minutes. What happened to the Galileo probe that we dropped in? It didn't hit anything. It just kept falling into Jupiter's environment, and the pressure kept going up and up and up. As it fell, it measured pressures 23 times higher than on Earth and temperatures over 300 degrees higher than on Earth. When you're in the environment of a gas giant and you go deeper and deeper into this soup of hydrogen, which has no solid surface, it can still be very heavy. And so eventually you would be crushed by the overlying weight of the material that's there. Even though the probe only went 124 miles down before it was crushed, it showed scientists what Jupiter's inside looked like. But the dark heart of the planet still remains a mystery. Like some rocky planets, the gas giants have a magnetic field too. Jupiter's magnetic field is 20,000 times stronger than Earth's and so big that it goes all the way to Saturn, which is more than 400 million miles away. Like on Earth, Jupiter's magnetic field keeps the solar wind away from the atmosphere and keeps it safe. When scientists looked at Jupiter's magnetic field, they found that it affected the moons of Jupiter. The volcanic moon Io orbits only 217,000 miles from the planet. Every second, Io's volcanoes send a ton of gas and dust into space. It gets even stronger because of Jupiter's magnetic field, which makes powerful belts of radiation. And this makes the area around Jupiter very busy in a lot of ways. If you point a radio antenna at Jupiter, you can hear how the planets and the magnetic field interact with each other. Jupiter and Saturn can make auroras without the solar wind. They make their own magnetic fields because they're so big. These auroras show that planets with gas also have magnetic fields. But how do magnetic fields get made on gas planets? On Earth, the job is done by a very hot liquid metal that spins around the planet's solid iron core. Most likely, gas planets do about the same thing. But gas planets don't have iron cores that get very hot. They formed around frozen cores of dust and ice, so we don't really know what's going on inside. We really don't know what makes up the deepest parts of Jupiter's interior. So, it's possible that Jupiter has a solid core at its center, or it could just still be liquid. We might never know. No probe could ever go the 44,000 miles to the center of the planet to look into it. Galileo was destroyed before it could reach the center of the planet. Gravity and heat shape how planets evolve, from their inner cores to their outer atmospheres. They're the great creative forces in planet building. But there's one more thing that has a big effect on how planets turn out, and that ingredient is water. Planets may look like they are fixed and don't change, but they are always changing. One planet in our solar system lost its atmosphere and turned into a desert. Another planet got too hot and changed into the planet from hell. Planet Earth has also changed, and it was water that changed the game. When you look at Earth from space, you can see a lot of water. We are, after all, the blue planet. That means it must be very wet, right? At first glance, our world seems to have a lot of water. After all, 3/4 of it is made up of oceans. Not true. Only 0.06% of the mass of the Earth is water. Some water is on the surface as oceans, and some is stuck in the mantle. But actually, the Earth is a relatively dry rock. All of the inner rocky planets formed very close to the Sun, so they started off dry. Any water they might have had either evaporated or was blown away when things hit. These massive collisions that formed the Earth were so energetic that if there had been water here, it would have evaporated and left the Earth. So where did all the new water on Earth come from? It's now here. When you look at Jupiter, Saturn, Uranus, and Neptune, you can see that they have a lot of water locked up inside them. And even more dramatically are the moons. At least half of the water on the moons of Jupiter, Saturn, Uranus, and Neptune. A lot of water was out there. So, how did some of it get to planet Earth? And the answer is almost certainly that there were some asteroids and comets left in our solar system that were far enough from the Sun that they could keep their water. There were millions of these watery asteroids and comets that flew into the inner solar system. Some of them crashed into our planet. Over time, the Earth got the water that used to be in the asteroids. This is what makes up the mass of water that now covers almost all of the Earth. Without surface water, there would have been no life. What about water that is too much? The oceans would be much deeper and cover the continents and even Mount Everest. And it's likely that the exact amount of water that the Earth has is what made it possible for us, Homo sapiens, to evolve into a technological species. About 4 billion years ago, a blizzard of comets and asteroids brought just the right amount of water to Earth. This is how the world we know today came to be. And it's possible that the same thing is going on somewhere else in the universe right now. There is a lot of water out there, that much is certain. The most common atom in the universe is hydrogen, and oxygen is one of the next most common. H2O will definitely be a very popular molecule, which is exactly what is happening in our universe. So, water is everywhere in the universe, and we're finding that planets are too. But we haven't yet found another planet where water is liquid. More than 400 new planets have been found by scientists. Our world doesn't look like any of them. What we haven't found yet is a planet around another star that is about the same size, mass, and chemical makeup as Earth. So, it remains an extraordinary holy grail for humanity to find other abodes that remind us of home. But we'll keep looking. We know that our galaxy alone has around 200 billion stars, and up to 40 billion of them could have their own planets. We are entering what will be called the golden age of planetary exploration in the future. We'll start to really understand for the first time how different things are out there. I think this is going to be a very exciting time. The laws of physics and chemistry tell us how planets are made. Many scientists think it's only a matter of time before we find another planet like Earth, one that formed from the same materials in the right place with the right amount of water. One thing is certain: there are billions of planets out there waiting to be discovered. Ladies and gentlemen, welcome to today's topic, aliens. Are they real? Do they exist? And if so, what do they look like? Today, we will dive deep into the topic of aliens, exploring various theories and facts about these mysterious creatures. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. Here are a few theories about aliens. Extraterrestrial life exists. This is the theory that life exists elsewhere in the universe, perhaps even within our own solar system. Microbial life could potentially exist on Mars, or some of the moons of Jupiter and Saturn, for example. More complex life forms, such as intelligent civilizations, could also exist on planets orbiting other stars. The Fermi Paradox. The Fermi Paradox suggests that if intelligent life is common in the universe, why haven't we detected any evidence of it? Some theories suggest that intelligent civilizations tend to self-destruct, while others propose that they are too far away or have no desire to communicate with us. Ancient aliens. This theory suggests that aliens have visited Earth in the past and have influenced human history and culture. Proponents of this theory point to ancient artwork and texts as evidence of alien visitation. UFO sightings. Unidentified flying objects are often cited as evidence of alien visitation. While many sightings can be explained by natural phenomena or human-made objects, some remain unexplained and could potentially be evidence of extraterrestrial visitation. The simulation theory. This theory proposes that our entire reality is a computer simulation created by an advanced civilization. While not specifically about aliens, this theory suggests that the creators of the simulation could potentially be an extraterrestrial civilization. To start with, let's address the most basic question: do aliens exist? Well, according to the Drake equation, which was developed in 1961 by astronomer Frank Drake, the probability of intelligent life existing elsewhere in the universe is high. The equation takes into account factors such as the number of stars in our galaxy, the number of planets that could potentially support life, and the probability of life forming on those planets. Using these factors, the Drake equation estimates that there could be millions of intelligent civilizations in our galaxy alone. But the question remains, have we ever encountered these civilizations? Many people believe that we have, and there are countless stories of alien sightings, abductions, and encounters. However, there is little concrete evidence to support these claims. So, let's explore some of the most popular theories about what aliens might look like. The traditional image of aliens as small, green, big-eyed beings is a product of popular culture. However, it is unlikely that aliens would look anything like this. In fact, it is impossible to predict what aliens might look like, as their appearance would depend on the conditions of the planet they evolved on. For example, if an alien species evolved on a planet with high gravity, they might have shorter, stockier bodies. If they evolved on a planet with a harsh, radiation-filled environment, they might have evolved to be more resilient to radiation. It's also possible that some alien species might not even have bodies as we know them. They might exist as pure energy or as a hive mind collective. But why would aliens visit Earth? There are a few possible reasons. Some scientists speculate that aliens might be interested in our planet because of its unique location in the universe. Earth is in a Goldilocks zone. It's not too hot, not too cold, and has the right conditions for life to thrive. Aliens might be interested in studying our planet to learn more about how life can survive in these conditions. Another reason aliens might visit Earth is to make contact with us. If there are millions of intelligent civilizations in the galaxy, it's possible that some of them are trying to communicate with us. However, if this is the case, they might be communicating in ways that we can't even comprehend. Their methods of communication might be vastly different from ours. So, what should we do if we ever do encounter aliens? Many scientists believe that we should approach any encounter with caution. We should avoid making any sudden movements or aggressive actions, as these might be misinterpreted by the aliens. Instead, we should attempt to communicate in a peaceful and non-threatening manner. If we do make contact with aliens, microbial life, and scientists have found evidence of subsurface oceans on some of Jupiter and Saturn's moons, which could potentially support life. If we do find evidence of microbial life in our own solar system, it would be a major discovery and could have significant implications for our understanding of life in the universe. Let's consider the potential implications of discovering intelligent life. If we were to make contact with an alien civilization, it could have profound impacts on our society and our understanding of the universe. For one, it could challenge our existing beliefs and worldviews. We might need to reevaluate our ideas about our place in the cosmos, our religious and philosophical beliefs, and our understanding of the origins of life. It could also raise questions about the ethics of interacting with other intelligent species and the responsibilities that come with such interactions. Another potential impact is on our technology and scientific progress. If we were to encounter a more advanced civilization, we could learn from their technology and knowledge, potentially accelerating our own progress. On the other hand, it could also pose a threat if the aliens have hostile intentions towards us. It's difficult to say for certain whether aliens, if they exist, would be dangerous to us. We have no concrete evidence of intelligent extraterrestrial life, and so any speculation about their intentions or behaviors is purely hypothetical. Some people argue that aliens could be dangerous if they are more technologically advanced than us and have the ability to conquer or destroy us. Others point out that any civilization advanced enough to travel through space would likely have a more sophisticated understanding of the universe and may be more peaceful and cooperative. It's also possible that aliens could be indifferent to us, simply observing us from a distance without any intention to interact with us at all. Overall, while it's fun to speculate about the potential dangers of alien life, the truth is that we simply don't know enough to make any definitive conclusions about their intentions or behaviors. The search for extraterrestrial life should be approached with an open mind and a healthy dose of curiosity rather than fear or paranoia. Regardless of the potential impacts, the search for intelligent life continues. We are constantly developing new technology and refining our techniques to search for signals and evidence of other civilizations. And while the chances of finding intelligent life may be slim, the pursuit of knowledge and discovery is a worthy endeavor in and of itself. That's all for today's topic of aliens. We hope you've enjoyed this discussion and learned something new. If you have any questions or comments, please leave them in the comment section below. Thanks for tuning in, and we'll see you next time. We inhabit a galaxy known as the Milky Way, which contains hundreds of billions of stars. How did we arrive at this point, and what is our future? These concerns involve galaxies in every aspect. The known universe contains 200 billion galaxies, each of which is unique, immense, and dynamic. Where do galaxies come from? How do they work? What is their future, and how will they die? If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. This is the Milky Way, our galaxy. Approximately 12 billion years old, the galaxy is a vast disk with enormous spiral arms and a central nucleus. It is only one of countless galaxies in the universe. Galaxies are massive assemblages of stars first and foremost. A typical galaxy could contain 100 billion stars. They are actually stellar nurseries, the locations where stars are formed and perish. The stars in a galaxy are formed in nebulas, which are concentrations of dust and gas. Our galaxy contains billions of stars, many of which have planets and moons orbiting them. But for a very long time, we knew very little about galaxies. A century ago, we believed that the Milky Way was the only galaxy in the universe. In 1924, astronomer Edwin Hubble altered the entire situation. Hubble observed the universe using the most sophisticated telescope available at the time, the 100-inch Hooker on Mount Wilson near Los Angeles. Far, far away, he saw hazy masses of light in the darkness of the night sky. He realized they were not even separate stars. They were entire star-filled cities, constellations far beyond the Milky Way. The astronomers received an existential jolt. We went from the Milky Way galaxy being the only galaxy in the universe to billions of galaxies in a single year. Hubble made one of the finest discoveries in the history of astronomy when he discovered that the universe contains a large number of galaxies rather than just one. This is the Whirlpool Galaxy. It comprises over 160 million stars and is characterized by two enormous spiral arms. In addition, the stars of the huge elliptical galaxy M87 shine with a golden hue since it is one of the oldest galaxies in the cosmos. And this is the Sombrero Galaxy. Its massive bright core is surrounded by a cloud of gas and dust. All galaxies are very beautiful. They stand in for the fundamental building block of the cosmos. As they spin across space, they resemble enormous pinwheels. Galaxies are enormous on a grand scale. On Earth, we measure distance in miles. In space, astronomers use light years. This is how far light can travel in a year. Our galaxy's diameter is over 100,000 light years, and we're now located at a distance of 25,000 from its center. However, in the grand scheme of things, even it seems like a tiny dot. While the Milky Way seems enormous from Earth, when compared to other galaxies, it is really rather little. Andromeda, the galaxy closest to us, is about 200,000 light years wide, making it twice as large as the Milky Way. M87 is the largest elliptical galaxy in our own cosmic backyard and much bigger than Andromeda. But M87 is tiny compared to this giant. 6 million light years across, IC 1011 is the biggest galaxy ever found. It's 60 times the size of our own Milky Way. It's common knowledge that galaxies are enormous and ubiquitous. But why is this the case? The origin of galaxies is a key mystery in astrophysics. Approximately 13.7 billion years ago, the universe began with what we refer to as the Big Bang, a period of intense heat and density. We know that there could not have been anything like a galaxy at that time. So galaxies must have come from that very early universe and formed from it. For stars to form, and for galaxies to form from those stars, gravity is essential. After the Big Bang, the first stars began to emerge only 200 million years later. The earliest galaxies formed as their masses began to clump together because to gravity. Thanks to the Hubble Space Telescope, we can now see the early universe when galaxies were just beginning to form. Numerous galaxies are visible to the Hubble, the light we see from distant galaxies now. However, really departed those objects many millions or perhaps billions of years ago. What we see now is the distant past of those galaxies since it took so long for their light to get to us. The Hubble Deep Field reveals a collection of fuzzy dots. They are quite different from the galaxies we see now. We can hardly make out these little specks of light. Those fuzzy patches of light are really millions or billions of stars beginning to combine. The oldest galaxies are represented by these barely visible blotches. They began to take shape around 1 billion years after the Big Bang. However, Hubble's range of visibility ends there. A second sort of telescope, one too large to send into space, is required if we are to travel much farther back in time. Not only can the telescope identify primordial galaxies, but it can also trace their evolution. The evolution of galaxy and galaxy cluster formation may be followed. All the galaxies that have developed since the cosmos was just a few 100,000 years old are leaving their imprints for us to observe. Finally, scientists can begin to answer the question, what did young galaxies look like? Galaxies have evolved from clusters of stars to the complex web of systems we see today, and this process is being seen by astronomers. As far as we can tell, the greatest structures in the universe today originated as star clusters, evolved into galaxies, formed clusters of galaxies, and ultimately coalesced into superclusters of galaxies. There was a lot of stardust, gas, and clumpy structures in the early galaxies. However, modern galaxies seem organized and tidy. When and how can tangled clusters of galaxies become neatly organized spirals and pinwheels? Gravity is the explanation. Galaxies are molded by gravity, and its effects determine their fate. At the center of most galaxies lies an unfathomably strong and destructive gravity source. And our own Milky Way has one hidden at its core. Over 12 billion years have passed since galaxies first appeared. These stellar conglomerations may take many forms, from spirals to giant spheres of stars, as far as we can tell. However, there is still a great deal we don't understand about galaxies. How did galaxies evolve into their present forms? Did spiral galaxies always have to be spirals? The answer is almost certainly no. Young galaxies are a mix of stars, gas, and dust. They are untidy and chaotic. They begin as chaotic formations, like the Whirlpool Galaxy, then over billions of years develop into more orderly forms. The Milky Way wasn't born from a single galaxy, but from a cluster of several. Our Milky Way originated as a collection of disparate formations, objects of varying sizes and shapes that gradually merged to become the galaxy we see today. Gravity is what binds the various components together. Over time, it gradually draws stars closer. They pick up speed and flatten out into a disk shape. Massive spiral arms gather stardust and gas. This process was carried out countless times during the course of the cosmos. While visually distinct, these galaxies share the fact that they all seem to circle the same central object. For a long time, researchers pondered what might possibly alter a galaxy's behavior. And they found out: a black hole. And not just any kind of black hole, but it's a supermassive black hole. The discovery of extreme amounts of radiation coming from the centers of certain galaxies was the first indication of supermassive black holes. Black holes in these galaxies are eating their surroundings, much like a giant Thanksgiving feast. The gas and stars are the supermassive black hole's dinner. Sometimes black holes consume their food so rapidly that they spew it out into space as beams of pure energy. They refer to it as a quasar. The presence of a quasar indicates the presence of a supermassive black hole at the center of the galaxy. However, what about the Milky Way? There's no quasar here. Does it rule out the existence of a supermassive black hole? Observing the motion of the stars is the key to finding the supermassive black hole in the heart of our Milky Way. Like the planets that circle the sun, the stars also move due of gravity. What we discovered was a bizarre and violent environment. At the center of our galaxy, everything is more extreme. Things move very quickly. The stars will be passing one another at high speeds. It is unlike any other place in the universe. The photographs of the stars in orbit showed a remarkable phenomenon. They had to have been traveling at 1,000,000 miles per hour or more. Only a gigantic black hole has the energy to toss large stars around like that. This curvature was the conclusive evidence for a supermassive black hole at the heart of our galaxy, as it is the black hole's gravity that drives the orbits of these stars. A massive black hole measuring 15 million miles wide sits at the heart of our Milky Way galaxy. So, is there any danger to Earth? We are in absolutely no danger of being sucked into our supermassive black hole. It's simply too far away. In reality, the distance between Earth and the supermassive black hole in the heart of the Milky Way galaxy is 25,000 light years. That's many trillions of miles. For the time being, Earth is secure. Although supermassive black holes are the source of enormous quantities of gravity, they are not strong enough to bind galaxies together. In reality, the rules of physics dictate that galaxies should accelerate away from one another. So what's stopping them? Because there's something stronger than a gigantic black hole waiting to be discovered. It is invisible and very difficult to detect. It's called dark matter, and it's everywhere. Supermassive black holes discovered by astronomers are found in the centers of galaxies and are responsible for the rapid movement of stars in their vicinity. However, they are insufficient to hold together all of the stars in a vast galaxy. So what does hold them together? It was a mystery until a maverick scientist proposed that something unknown was at action. Fritz Zwicky, a Swiss astronomer, pondered in the 1930s why galaxies clustered together. He reasoned that because they weren't producing enough gravity, they should be flying apart. However, the force of our own gravity was insufficient. Therefore, he deduced that it must be something that had never been discovered before, something that had never even been considered, and he called it dark matter. Fritz Zwicky was decades ahead of his time, and that's why he graded on the astronomical community. And this is a brilliant idea, but he was correct, you know. It's possible that individual galaxies are also held together by the mysterious substance that Zwicky dubbed dark matter. Galaxies rely on dark matter as a kind of protective framework that keeps them from collapsing and moving about. Now, scientists have discovered that dark matter does more than just bind galaxies together. It may have also triggered their evolution. Scientists believe that after the Big Bang, dark matter started to cluster, and these dark matter clumps evolved into the galaxy's nucleus. However, the nature of dark matter is still a mystery to physicists. Weird things happen with dark matter since we don't know what it is. Obviously, it's not constructed from the same substance that humans are. You can't push against it. You can't feel it. However, it is likely everywhere. It's a ghost-like material that will pass right through you as if you didn't exist at all. Although our understanding of dark matter is limited, it seems to be abundant across the cosmos. That means there must be at least 6 times as much dark matter as regular matter, what humans are comprised of in the cosmos. And the way the cosmos seems to function depends on it. Observations of its effects on light have led to its recent indirect detection in deep space. Through a process known as gravitational lensing, it warps the light. The existence of dark matter may be tested using gravitational lensing. As a ray of light from a distant galaxy travels towards us, its course will be bent around a huge collection of dark matter due to the latter's greater gravitational attraction. Some distant galaxies indeed seem stretched and warped when seen via the Hubble telescope. The picture distortion is due to the presence of dark matter. We can determine the density of dark matter by carefully examining the forms and degrees of distortion of these galaxies. Now more than ever, the importance of dark matter to the cosmos is undeniable. It's what makes galaxies form and stops them from collapsing. Even though it's invisible and undetectable, dark matter rules the cosmos. These galaxies seem to be completely alone. It's true, they are trillions of miles apart. But actually, they live in groups called clusters. And these clusters of galaxies are linked together in superclusters, containing tens of thousands of galaxies. The Milky Way's place in the cosmos remains a mystery. If you look at the overall image, you'll see that our galaxy is associated with a smaller group of galaxies, including about 30 members in total, and that our galaxy and Andromeda are the two largest members of this group. Further observation reveals, however, that our galaxy is embedded inside the Virgo supercluster. Researchers are now making maps of galaxy clusters and superclusters to better understand the cosmos. Galaxies are the immense star empires. The shapes range from enormous balls to intricate spirals. The problem is that they are always evolving. When we stare out into the cosmos, it's easy to assume that our galaxy hasn't changed in eons. It's not. The Milky Way is a dynamic galaxy. Over cosmic eons, its basic nature has been changing. Galaxies don't only evolve, they move as well. And sometimes they run into each other. The two galaxies will merge over millions of years when they collide. This kind of collision occurs all the time in the cosmos. Our own Milky Way is no exception. We are on a collision course with the galaxy Andromeda, and that's terrible news for the Milky Way. At a speed of around 250,000 miles per hour, our Milky Way galaxy will collide with Andromeda in about 5 billion to 6 billion years. It's all over for the Milky Way galaxy. If you could look out into space, you'd see the whole Andromeda galaxy hurtling toward us at a tremendous rate of speed. As the two galaxies interact, they both become more and more disturbed and closer together. There will be a dance of death between the two galaxies. Whenever galaxies collide, they release clouds of gas and dust in all directions. As galaxies collide, their combined gravity rips stars from their orbits and launches them into the void. As we approach doomsday for the Milky Way galaxy, it would be spectacular. The two galaxies will ultimately pass through one another and merge into a single one. The Milky Way and Andromeda as we know it will cease to exist, and Milkomeda will be born, and it will look like a whole new galaxy. There's no escaping what's going to happen. The question is, what's it mean for planet Earth? We may either be thrown out into outer space when the arms of the Milky Way galaxy are ripped apart, or we could wind up in the stomach of this new galaxy. Stars and planets will be pushed all over the place, so this may well be the end of planet Earth. Galaxies all over the universe will continue to collide. But this age of galactic cannibalism will eventually pass. Because there is an even more destructive force in the universe, a force that nothing can stop. It will eventually tear the cosmos apart by stretching everything to the point that galaxies are pushed apart from one another. Researchers have identified a new cosmic power. It's called dark energy. Unlike dark matter, dark energy has the opposite effect. It pushes galaxies apart rather than bringing them together. Dark energy, which we've only discovered in the last decade and which dominates the universe, is significantly more enigmatic. We don't have the slightest idea why it's there. What it's made from, we don't really know. We are aware of its presence, but beyond that, our understanding of it is limited. Dark energy is really weird. Things resist and are pushed away from one another as if space itself contained tiny springs. In the far future, scientists predict that dark energy will triumph over dark matter in the cosmos. And with that triumph, galaxies will finally begin to drift apart. Galaxies will eventually die off due to dark energy. It will do this by accelerating the expansion of the universe, forcing all galaxies to recede farther and further away from us until they become invisible and travel faster than the speed of light. Therefore, everything else in the cosmos will vanish before our own eyes. The remainder of the cosmos won't vanish today or tomorrow, but it may after 1 trillion years. Galaxies will be left alone in the void. However, this will not occur for an extremely lengthy period. The cosmos is doing well right now, and galaxies are creating favorable circumstances for life to exist. Without galaxies, I wouldn't be here. You wouldn't be here. Maybe not even life itself would exist. This is fortunate for us. The only reason why life has evolved on Earth is because our minuscule solar system was formed in the correct region of the galaxy. If we were any closer to the center, we wouldn't be here. Life in the center of a galaxy may be extremely hazardous. In point of fact, the proximity of our solar system to the core of our galaxy would render it so radioactive that it would be impossible for life to continue in any form. Too far away from the center would be just as bad. Out there aren't as many stars. We might not exist at all. We are therefore, in a sense, in the Goldilocks zone of the galaxy. Neither too close nor too far away, but just right. There may be millions of stars in the cosmic Goldilocks zone, where conditions are just suitable for life. Furthermore, if our galaxy can support life, then other galaxies should be able to as well. The cosmos is very large, and the really incredible part is that we continue to learn new things about it. Every time we believe we've figured out a solution to an issue, we uncover that it's really part of an even greater one. That's awesome. Our Milky Way galaxy and the galaxies beyond it are rife with mysteries and unanswered questions. Who would have guessed 20 years ago that we would be able to identify the black hole at the center of the galaxy? Who would have predicted 20 years ago that the astronomical community would accept the existence of dark matter and dark energy? We should be astonished to be alive at this particular moment in cosmic history, on this particular planet, on the fringes of this particular galaxy, with the ability to ponder questions and seek answers across the whole cosmos. Galaxies are born, they evolve, they collide, and they die. The Milky Way is a fortunate home for intelligent life. Our fate is intertwined with that of every galaxy. Ultimately, our fate rests in their hands since they are the ones who created us and are shaping our identities.